Hello, today we will be looking at two ways to reduce image data. Before I begin the video, don't forget to like and hit subscribe, and if you have any questions, comments or suggestions, please leave them in the comment sections below. There are two ways to reduce the image data. One is spatial reduction and the other one is gray level reduction. When they are performed on spatial coordinates, they are called as spatial reductions. When they are performed on pixel values, they are known as gray level reduction. Let me explain the difference here. I took the liberty of drawing these diagrams off camera because honestly, who wants to see me draw diagrams? Suppose if this is our image, and this little box here is our spatial coordinates, this is our spatial coordinates, and the intensity value for this here is represented by this value 50. This is the pixel value. So this is the so when we reduce it in this part, there it's called spatial reduction. When we reduce it here, it's called gray level reduction. So the process of reducing image data is usually done by removing some detailed information by mapping groups of points to a single point. Suppose this whole image or this group of data we represent, suppose it contains lots of values. This coordinate has another value, this coordinate has another value, and so on. If we represent this whole thing with a value of suppose 100, this is how we reduce data. This is how we reduce data. Let me select my highlighter. We map groups of data to a single point. Operation on pixel values is known as gray level reduction, and operation on spatial coordinates is called as spatial reduction. The simplest method for gray level reduction is thresholding. Now, how do we do thresholding? First of all, we select a threshold value, and we set everything above that value to 1, and we set everything below that value to 0. If we take this pixel values in consideration, suppose this is how we set our conditions. Pixel values greater than 128 is 1, and pixel values lower than 128, lower than or equal to 128 is 0. This is our condition. Now, if we use this, how do we do the thresholding here? 129 is greater than 128, so the value is 0. 40 is less than 128, so 0. 50 is less than 128, so 0. Again, 60 is less than 128, 0. 250 is greater than 128. 250 is greater than 128, so 1. 240 is also greater than 128, so 1. 70 is less than 128, so 0. 80 is also less than 128, so 0. 200 is greater than 128, so 1. Therefore, we can see that we have represented this image or this set of pixel values as this set of pixel values. Here. This pixel values is represented as this pixel values after thresholding. So this turns a gray level image into a binary image, because we know that 1 stands for white and 0 stands for black. Why did we select 128 as our why did we select 128 as our threshold value? From basic computer fundamentals, we know that if a data is represented with 8 bits, then the possible combinations or the possible levels for that is 2 to the power 8, which is equal to 256. Excuse my handwriting. Now, if so the reason why I chose 128, because 256 divided by 2 is equal to 128. This is how we choose the values. Now, can someone write it in the comment section below? What would happen if instead of 8-bit data we used 7? How would we choose the values? Show me using an example in the comment section below. Thresholding is the first method of gray level reduction. The second method that we are going to use is gray level reduction with AND and OR masks. Now we can perform a logical AND and OR mask with a bit string mask to do gray level reduction. Let me explain this with an example so it will be clearer. Suppose I have 8-bit information, which means it contains 256 possible gray level values. Now we need from 256 possible gray level values, we need to bring it down to 32 possible values. How do we do it? Let me select my typewriter. As we know that here 2 to the power 5 is equal to 32. Since we know that 2 to the power 5 is 32, what we do is we write 5 ones because it's 2 to the power 5. And the remaining, we know that we used an 8-bit information, so the remaining 3 bits, to make it 8, we put it as zeros. Suppose instead of 32, we had to bring it down to, suppose we wanted to bring it down to 16. How would we do it? Now let me show this example again. Let me do it somewhere here. So 2 to the power 4 is equal to 16, which means we have to put 4 ones. And the remaining, how many digits are remaining to make it to 8? 4 more. We are going to put 4 zeros. This is gray level reduction using AND. This is using AND. Now, how would we do it for OR? Okay, let us use the same example. We have 256 gray level values. We wanted to bring it down to 32. So, let me select my typewriter. 2 to the power 5 is equal to 32. Now, instead of putting 5 ones, we're going to put 5 zeros. And the remaining 3 digits, which will be needed to make it to 8, because we use 256 gray levels, which means we need 8 digits, will be 1, 1 and 1. Now, can someone tell me how this will be if we use 16? And can someone show me the explanation of why we did it this way? This is a trick question, and I'm hoping at least one of you get the answer right here. Before I move on to spatial reduction, let me summarize our gray level reduction. We learned 2 methods for gray level reduction. Gray level reduction uses pixels. It's done on the pixel domain, and we learned 2 methods. Number 1 is thresholding, and number 2 is gray level reduction using AND/OR masks. Now we move on to spatial reduction. Let me select my highlighter. Now we move on to spatial reduction, which is also called as spatial quantization. This can be performed in three ways: averaging, median, median and decimation. Okay, so what do we do in spatial quantization? We reduce the image size by taking groups of spatially adjacent pixels and mapping them to one pixel. Let me draw and explain this better. If this is our image, we take this group of image and 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 we form a new image using these blocks. Suppose this block goes here, this block goes here, this block goes here, this block goes here. As you can see, we reduce the image size. We take groups of spatially adjacent pixels and we map them to one pixel here. We map them to one pixel here. And we take this group and we map them to one pixel here. Take this group and we map them to one pixel here. Now, three ways we do this are averaging, median and decimation. For the first method, we take all the pixels in a group. We take all the pixels, suppose we take all the pixels in this group. We find the average gray level values by summing up all the values and dividing it by the number of pixels in this group. And we replace this entire group of pixels with the single value here. This is for the first method, averaging. With the second method, we sort all the pixels from lowest to highest and we select the middle value. We order all the pixels in this group from smallest to largest, which means in an ascending order, which means we do it in an ascending order, and we replace this group with the middle value. Once we have done the median value, once we have done the ascending order, we select the median value and we do it with and we replace it. Suppose this is the median value. 1, 2, 3, 4, 5. In this case, 3 is the median value. What would be the value of the value if this was a set of pixels? What would be the median value for this? Show me the working and leave it down in the comment section below. Now, the third approach is decimation, which means subsampling or eliminating some of the data. Let us do this with an example. Suppose this is the value 1, 2, 3. Now, if we want to do decimation, what we do is 1, 3, 5, 1, 3, 5. What we did was we eliminated some of the data. If we take a factor of 2, we simply take every other row and column and delete them, which means we took this data, we removed this, and we removed this column, and we removed this column. Then this is the remaining data that is left. This is known as decimation. We have reduced the data. That is our main point. So, there are 3 types of spatial reduction methods: averaging, median, and decimation. If someone can summarize this down in the comment section below, it will help everyone. Let me select my typewriter and move on to some of the examples. This is the original image. This is the original image. Once we do spatial reduction with averaging, we get this. Once we do it with median, we get this. Once we do it with decimation, we get this. In all of the above, the amount of data has reduced. Okay, so this will be enough for today. I hope you've understood everything, and if you have any questions, leave it down in the comment section below. Thank you.